Hello everyone, welcome to the fifth tutorial video for Intel Galileo Gen 1 development board. In the fourth video, we saw how to boot up Galileo through SD card, and we also executed a Python script to blink an onboard LED via Linux console. In this video, we will see how to host a web page on Galileo with Node.js. Later in this video, we will also write a Python script to host a web page on Galileo and control the onboard LED through this page. Let us first start by creating our HTTP server with Node.js. Node.js is available both in the Galileo Linux image provided in the Flash as well as the image we saw in the video tutorial 4. Before starting, we will check if the Node.js package is installed. To check this, we will look for node in /user/bin, or we can simply type node on the shell. If Node.js is not installed, we can install it through opkg, which is the package manager available on the Linux image provided for Galileo. We will mainly use two commands to install a package. First one is opkg update. This command is used to update the versions of all packages and make them available to install on the system. Second command is opkg install followed by package name. As the name suggests, this command is used to install the package on the system. In order to install the package, we first need to make sure that the package is available in our kernel. There are many repositories online which contain packages we will need while building our applications. To make these repositories available to our kernel, we will have to add the paths to these online repositories to one of the files inside /etc/opkg. We can give any name to this file. We will make sure that the extension to this file is .conf. I have already created multiple .conf files. We can also just have one .conf file with all the paths added in this file. I will open one of these files, say iotdk.conf. Here we can see the path of the repository. We will make sure that the path we give here should have a file named packages inside it. So when I copy paste this link on the web browser, we can see this file which I was talking about. This file contains the information about all packages that will be installed. Please note there may be a lot of additional packages available in this path whose names will not be included in the packages file. So even after we do an opkg update, these packages will not be downloaded and will not be able to install them. For such packages, we will explicitly need to download them using wget on our system and then do opkg install. Please follow the link given on the screen for more details about opkg. So now once we make sure that Node.js is installed, we can create our HTTP web server. We will write a Node.js script called web.js. We will begin by including all the required modules like HTTP, FS, which is file system, and URL. For more details on each API, please follow the link given on the screen. Next, we will create variables for our host and port names. To check for the host name, we will type ifconfig on the shell. We can provide any port number as far as it does not conflict with the standard set of port numbers. I shall use 3356 here. Then we will create our HTTP server. We will write a function to read from the HTML file specified in the URL. If the HTML file does not exist in the required path, then the page will display an error message. Next, we will type server.listen to begin accepting connections to this host specified by the port number. The console.log will enable prints on the shell. Now we will save the file and execute it. Next, when I type node.js blink_led.js, you can see message server listening at host number : port number. If the HTML file is not present and when I open any web browser and type URL host port name, it gives a page not found error. Now if I create an index.html file with a simple head and body, then we can see the contents of the file. Similarly, we can type any file name after port name and /.html file of this name will be looked for in the folder. After successfully hosting a web page, in the second part of this video, we will look into a Python script which will host a web page over Galileo so that we can control and onboard LED through it. So as discussed in the earlier part of this video, we will first import certain modules required to create an HTTP server using a Python script. Then we will specify the port number and set a variable named blink equal to true. After this, we will have a class which will handle all the requests coming from the browser. Here we will place our functions for get and post request methods. Get request methods are designed to retrieve information from the server. It is usually used wherein data is passed in the URL's query string, such as passing the HTML file name in our case. So as seen here, if we just put a slash after the port number while sending a request to the server through a browser, by default it will pick up index.html from the current folder if it is present, else it will throw an error. If we write any text followed by the slash, the server will try to find the HTML file of that name and throw an error if it does not find it. After this, we will write a function for post request method. The post request method requests that the target resource process the representation enclosed in the request according to the resource's own specific semantics. So, we will create a form with the help of CGI module and check for the value of either stop or start blinking. If we receive a value of stop blinking, we will set out variable blink to false, else set it to true. We will send an HTTP response 302 and set the location header to self-indicating a URL direction to the page after processing a request. We will now write a web server thread that will create an HTTP server as discussed in the first part of this video and continuously run by using server_forever function. We will close the server socket using function socket.close if a keyboard interrupt such as Ctrl+C has been encountered. After this, we will simply write again the same functions that we saw earlier in video 4 to blink and onboard LED using a Python script. Only difference we will see is in the main while loop, wherein we check the status of variable blink and blink LED on or off accordingly. We will now save and close the file. Next, we would create a simple HTML file that will be active while server processes a request. We will open a new file named blink_led.html. Following the syntax of HTML scripts, we will start by writing an HTML file, followed by a fancy heading to our page. Let us call it as blinking LED control. Next, in the body of the HTML file, we will create a form that will be processed by the post request method. We will create two fields in the form, say stop blinking and start blinking. Since we have not specified any format options, this will use basic HTML format settings. We can edit and beautify the HTML in many ways by following tutorials available online. We will now close the body of the HTML file and save the file. Once we have the Python script at the HTML file ready, we can test our script. I shall execute the Python script. When I hit enter, we can see a standard HTTP server at port message on the console. Let us now open our browser and try sending a request to the server. I will type IP address followed by a colon and port number. which is followed by / and blink.html. We can now see the interface provided by our HTML file. Initially, since blink is equal to true, the LED is continuously blinking. When I hit stop blinking, LED stops blinking. Now when I click on start blinking, the LED blinks continuously. So this ends the basic demo for many such web server based applications. Thank you for watching this video. I hope you enjoyed it.